I'm Gary Archer from Curity, and I'm going to do a talk on AI security from the viewpoint of enterprises. So it will be a fairly technical talk, but hopefully not too bad, not too painful, and maybe 20 minutes or so. So because I realize you've been here quite a while. Oops. So a little bit about me. I have a teaching role on API security and identity. So I do a lot of writing articles, a bit of presenting, as you can see, code examples, etc. I'm one of the authors of this book, and it's all about API first thinking, API first security, and it's very relevant to the world of AI. So I'm going to cover some of the techniques today. So the first thing you notice about AI is it's an interoperable ecosystem, so built on interoperable protocols. And to do anything useful, you need data. And there's two protocols that involve security. One of them is called Model Context Protocol, or MCP, and the other is called Agent-to-Agent, or A2A. So typically in this kind of ecosystem, you write a server, and clients use interoperability to connect in predictable ways. And therefore, you need to use interoperable security as well, right? And so when you do, there's typically three main requirements. You need to, authenticate humans operating the agents. You should aim to authenticate the agent itself so that you know a malicious program is not calling you. And most importantly of all, the agent should get least privilege access to your business data. So you should be in control of what the agent can do. So as some of you may be aware, MCP has an authorization specification. It's a profile of OAuth. And OAuth is basically end-to-end security for APIs, many types of clients, and for users. It's vetted and interoperable, and it gives you this end-to-end security, which is typically what you want at enterprises. So some of you may have used MCP authorization. Any of you guys connected MCP to OAuth? Yeah, so when you do, typically, this diagram here represents the kind of use case where people often get started, like an employee might use something like Claude Desktop or ChatGPT. What you do is you register an MCP server URL, and then the agent like ChatGPT or something will use an MCP client to connect to the server. So the user will get redirected to log in, and then eventually the MCP client gains access to MCP servers and to APIs. And the most important part of this access is the access token, because the access token controls what the agent can do with your business data. So the access token is a lot more important than people sometimes think. So really, when you think of AI agents, often they're a new type of user agent. Certainly the chat clients are anyway. Typically, if you're an enterprise, you've got maybe 10 years of existing investment in APIs. So you've built many APIs. And MCP can call those existing APIs as tools. So API endpoints can be selectively exposed to the agent and used to provide data to the large language models that the agent uses, and therefore users can crunch their own data in interesting ways, get reports or PDFs or whatever they need. So there is a bigger picture though, because typically as well as meeting your AI requirements, you have many other types of API clients, right? This is one deployment, but another deployment of interest is a use case that a lot of enterprises want, is to have a customer service portal where the user can ask a natural language question, and that can use the A2A protocol, so you can run an agent in the back end. Sometimes you can apply better security in the back end, and all that changes then is that the MCP stuff happens in the back end. Both MCP and A2A, they use OAuth, they use access tokens, and the access tokens control the level of access. So many people use OWASP, right? You probably many people here, you're a developer, you've used OWASP before and you've connected to various systems. It's a low-code technology. In OWASP, you should never write much code to actually deal with OWASP. They're just very lightweight messages, validate a JOT access token or run a code flow. These things are low code. But often what's true is that many organizations use OWASP suboptimally, especially when it comes to access tokens. And access tokens can easily allow too much access. So in the world of AI agents, it's even more important that you restrict access so that it's time-based and has limited permissions to your enterprise resources. When getting started on exposing sensitive data to AI agents, it's recommended to sort of do a bit of thinking about your API architectures and whether they're ready for it and whether you have the right ingredients. So, for example, many APIs, most developers would ensure that, user A can't access user B's data. That's pretty common. But often there's two big problems with APIs, especially at scale, and these are security boundaries and the kind of AI context that you need. So one picture that you quite often see is a kind of API sprawl with access tokens where different teams kind of go about things their own way. They use different token issuers. They maybe don't have any shared principles for how they handle tokens, or maybe not enough, or maybe there's a bit of a lack of governance going on. So what I'm going to suggest is some ways to deal with that kind of problem. And really, access tokens are the way you should think of them is they are the gateway to your business data. So it's not just a technical concern; it affects your business people, compliance teams, various roles within the organization. And what you can do is you can design access tokens in terms of your business, and you tend to get better results that way and a better shared understanding. And as I say, you get those kind of shared principles. So the way that you go about designing tokens in terms of your business is you use a centralized token issuer called the authorization server. And this would give you very complete control over what goes into the access token so that you can define your own policies, give your APIs the right information, because access tokens get delivered to APIs ultimately, and it's the APIs that provide that enterprise resource access. So it's all about getting the access tokens right, making sure you've got the right human approvals and so on. And to sort of solve that problem, you use what I consider to be the two biggest building blocks of OAuth, which are scopes and claims. I'm going to talk about scope. So scopes define security boundaries, and that's really all they do. Security boundaries for areas of your data and operations on that data. So often a good approach when you start looking at scopes for your organization is to design it in terms of areas of the business. So for example, you might have retail and commercial areas of the business, and an API endpoint that deals with retail functionality wouldn't accept an access token with a commercial scope. Right? Pretty straightforward. And sometimes you introduce high privilege scopes. That's another reason to introduce scopes. So for example, if commercial legal contracts is a particularly sensitive area, then you use a separate scope for it that you wouldn't give to an AI agent, that you give to very few clients, and maybe requires strong user authentication or something. So, so the idea behind naming scopes after business areas is that more people would understand it. Security administrators will understand scopes based on domain keywords, so will the business, so will the compliance teams, so should your engineers, right? And consent is an important area as well, because consent is very relevant actually when a user's data is being provided to a large language model. the user may or may not want that. So there's some advantages because the user can ask questions about their data in new ways, but some users might not want it. So therefore, you can use a consent screen that informs the user about the areas of data and various attributes. You could even put on here, your data will be released to a large language model. Are you happy with that? Blah, blah, blah. So respecting user privacy and the data owner's privacy is a big part of OAuth. And after the event, when you go live, typically these days, APIs and the authorization server can write audit logs. You can aggregate those logs. People can see how scopes are used at scale, by which AI agents, and this can bring a kind of organization to your large-scale API access. So, you can ask questions like, which agents have been using which scopes, and monitor how well security is working, whether anything unexpected is happening. But scopes don't help you with authorization, really. All they do is set boundaries. So to do authorization, you need claims, and claims give you the main values you need for authorization. And claims is very much an extensible ecosystem as well. So, APIs, what we recommend at Curity is that every API receives a JSON Web Token format of access token. And on every single request, they can cryptographically verify the token. If it's ever tampered with, the API rejects it. So this means there's a secure mechanism for delivering AI context to your APIs, and it can't be forged, right? So if you say in a token that an AI agent is present, no AI agent can lie about that, as we'll see. And one interesting thing about the authorization server is one of its roles is a collector of claims. So a good authorization server can use many security standards to connect to external systems and get claims in various ways. So I'm going to try to explain something that links to Maria's talk from earlier. So one of the things coming later in 2026 is this EU mobile wallets initiative that some of you may have heard of. And the idea is that for the HR use case we heard about earlier, the user can authenticate with a mobile wallet and release attributes about themselves. So Maria will be much happier because she'll know who people are. She'll get like claims like the degree type and the nationality, etc. And there'll be, obviously it takes a while for systems to catch up with technology, but that's the idea, is that once a user's authenticated, this, and it's strongly verified using cryptography. And so that's one of the things that claims give you. It gives you this extended business reach, and ultimately the authorization server issues access tokens, and the access tokens contain attributes that enable the correct authorization in your APIs. So the end-to-end mechanism can be a little bit complicated, but as I said earlier, there's very little code involved at the application level. For APIs, the job is very easy. So, in AI use cases, security requirements can be more dynamic. For example, an authorization server could get a risk score or something from a risk engine or something, and potentially issue that to an access token in a very dynamic way and give that to APIs. So, not sure if that made sense, but ultimately it's about what your APIs receive. So if you've got your orders API, customers API, etc., they receive useful information. So this is the most important slide, I would say, in my presentation today, because it's really the empowering your APIs with the right information to authorize AI. So those of you who've read about Curity stuff may have heard that we recommend returning opaque access tokens to the outside world, to internet clients. And these are like random strings, like UUIDs. They're unguessable, but you can't read what's in them if you're an internet client. And when that token flows through the API gateway, it gets exchanged for a JOT access token. And the JOT access token has claims that the API needs. And one of the things about scopes that's very important is when you issue a scope to an access token, you can issue a collection of claims. And so there's a relationship between scopes and claims. So in this example, we have a commercial order scope. We have some kind of an American administrator from a business partner. And we also inform the API that an AI agent is present. The client type is AI agent. So it's very easy for the API developer to adjust their authorization, and maybe a US administrator maybe usually can do many things, but in an AI context, you can reduce the what the user can do, maybe to 3 safe operations or something like that. Hope that makes sense. So it's easy for the API to deny access to certain operations once it has this attribute here. So it's all attribute-based access control that OWASP does. So that's probably the main things to understand is scopes for security boundaries and claims for the dynamic context, information from external systems. And with OAuth, you get this separation of concerns, you get a few more endpoints and things, and a few more messages flying around, but it simplifies application code and makes it easier to change. There are a few other important patterns just to finish. I've got three things just to finish. One of them is, when possible, use strong client credentials for agents to make sure that a malicious program isn't calling your APIs. So whether you can do that depends a little bit on where the client runs, but for backend clients, so for backend AI agents, you can use things like workload identities. One example is a Kubernetes service account token, and those kind of workload identities are basically they're a token for authentication, and so some authorization servers will allow you to send a token for authentication and get back an access token, which is the token for authorization. So they've got very different, even though they're both tokens, they've got very different properties from a security viewpoint. Next thing is around human approvals, because humans should be in control of agents, and OAuth has mechanisms to ensure that. We saw it with the consent screen, we saw it with the administrator configuring which scopes a client is allowed. And one interesting use case is that some AI workflows are quite long running, right? You might say to, a person might say to an AI agent, book me a flight when the price gets under $200 or something. And so it can be long running, and by the time it needs to complete, the user is no longer present. So one pattern that OAuth gives you is called the CIBA flow, and this is typically to complete a transaction, the AI agent needs to get an access token with a high privilege scope, a high enough privilege scope to, you know, book that flight and pay for that flight, perhaps. And so it can reach out to the user and use some kind of mobile notification to get verification and approval, and get that high scoped access token so that it can complete its task. So, you know, it's just worth being aware of that all of these design patterns exist in OAuth. There's many specifications that experts have thought about, and they're all available for you to use if you want to use them in AI use cases. And last but not least, there's one other pattern I want to mention, which is called token exchange. It's going to be very common in AI workflows, which get more automated and can potentially go across organizations. So this will be a fairly common flow where there's a 3-token flow where you do an exchange when the token first reaches the back end, and then the agent calls an upstream API and needs to get a different token. So it's all about, for each resource server, it's all about delivering the optimal token, again, with useful scopes and claims. And there are some emerging standards that allow token exchange across organizations as well. So like I say, people are thinking about these things. So from a future possibilities viewpoint, it's very useful. So really, OAuth is often misunderstood. It's not about logging in, it's about the access token, and it's about the organization it can bring to an enterprise, a large-scale access. So obviously, you need to make trade-offs. Before you give data to an LLM, you know, is the owner of that data happy about it? Is there any potential negative impact on the business? Does it break any compliance rules? And if you can get this kind of people alignment around AI objectives, and show that you're controlling the access, you can make trade-offs like allowing AI to use low to medium sensitivity data, but maybe not the high sensitivity stuff. Yeah, so, and like I say, OAuth evolves. So as AI initiatives evolve, it'll continue to do so, but it usually comes down to these three main things: human in the loop mechanisms, user authentication and approvals, authenticate the agents, and most importantly, lock down access tokens so that you restrict what agents can do. So that's it. That was quite technical. I hope it made a little bit of sense. If you're interested, there's some resources on the Curity website. So we separate our stuff into non-vendor specific design pattern-based stuff. So all of those articles there are not specific to our product. They are just general design patterns. And similarly, if you scan that QR code, I think you can download an electronic copy of that book in case you're interested. It's quite nerdy and it's all about tokens, so it's not for everyone. But like I said, there's business value behind this. You can bring organization and extend your business reach potentially using OAuth and AI together. So that's all I had.